All right, let's get right into it. If you're prepping for a senior .NET interview, you know it's not just some trivia quiz. It's a real test of everything you know, your C# skills, how you build things, and how you think about the big picture. So what we're going to do here is give you a game plan, a way to break it all down so you can walk in ready.
So, yeah, that's the million-dollar question, right? How do you actually ace this thing? Look, it's not about cramming a bunch of answers you found online. It's really about deeply understanding why you make the choices you do when you're coding. Our goal is to hand you a roadmap, a way to organize your prep so you can feel totally confident.
Okay, so we're going to think of this as the interview gauntlet. It's got 4 main stages we'll walk through. First, the core language gauntlet. Then, building modern web apps. After that, we'll get into the architect's view, and we'll wrap up with a final challenge, proving your experience.
All right, first up, the core language gauntlet. You know, before you could talk about building massive systems, you've got to prove you know C# inside and out. This is where they really test your fundamentals. You might see a question like this and think it's kind of small, but wow, does it tell an interviewer a lot about you? Let's break it down. Ref means you have to give it a value first, and the method you call can totally change it. Out is different. You don't have to initialize it, but the method has to give it a value before it returns. And in, that's the performance booster. You pass it by reference, so it's fast, but it's read-only. Nailing this stuff shows you're precise, that you care about the details.
Okay, these 3, they're like a team that works together all the time. A delegate is basically a blueprint for a method. It says, hey, any method that wants to work with me has to look like this. An event is like a radio station. It uses that delegate blueprint and shouts out, something just happened. Then other parts of your code can subscribe to that event. And Lambda expressions, they're just a really clean, short way to write those subscriber functions. This whole trio is the absolute heart of event-driven programming in .NET. Memory management. This is a classic question for senior roles. The .NET garbage collector does this little 3-step dance to keep things tidy. First, it runs around and marks everything that's still in use, all the live objects. Then it sweeps away all the junk, the stuff that's no longer needed, freeing up that memory. And finally, it compacts everything left, pushing it all together to keep the memory neat and tidy. Mark, sweep, compact. Simple, right? Okay, this one is a big deal. You absolutely have to know your concurrency. Think of it like this. A thread is the raw, low-level thing that the operating system gives you. A task is a much smarter, higher-level idea. It's a piece of work that .NET manages for you super efficiently. And then async await, that's the magic. It's the clean syntax that lets us write asynchronous code that doesn't tie everything up, but it reads almost like normal, simple code. A senior dev knows exactly when to use which one to make their apps fly. And here we have the solid principles. If C# is the language, solid is the grammar for writing beautiful, maintainable code. You've got single responsibility, open/closed, list-off substitution, interface segregation, and dependency inversion. And you can't just list them off, you have to explain what they mean. At the end of the day, these principles are all about one thing: building software that you can change and add to without breaking everything. It's about future-proofing your work. And that really sums it all up, doesn't it? This stuff isn't just trivia for an exam. Interviewers ask these deep dive questions to see if you truly get it. This is the stuff that separates the senior developers from everyone else. Okay, so you've nailed the fundamentals. Let's move on to the next part of the gauntlet. Now it's time to prove you can take all that C# knowledge and actually build something with it. Modern, powerful web apps and APIs. Yeah, you're pretty much guaranteed to get asked about this. The short version? .NET Core, which we just call .now, is the way forward. It's cross-platform, so it runs everywhere: Windows, Mac, Linux. It's super fast and modular. The old .NET framework, that's Windows only and basically just getting security updates. Knowing this difference is just table stakes. It shows you're current. This is such a fundamental concept in ASP.NET Core. Just picture an assembly line. A request comes in at one end, and it travels down this pipeline of different middleware components. Each component gets to look at the request, maybe do something to it, like check if you're logged in, and then it passes it to the next one. On the way back, the response travels back up that same line. It's a really elegant way to handle things like authentication, logging, all that good stuff. So when do you use Web API versus MVC? It's actually a pretty simple choice. They're built on the same foundation, but they do different things. If you're building a website that sends back full HTML pages to the browser, you use MVC. If you're building an endpoint that just sends back data, JSON for a mobile app or single-page application, you use Web API. It's all about picking the right tool for the job. And if you're building a web API, you're almost definitely going to be following REST principles. So what does that mean? It means you use the language of the web properly. You use HTTP verbs like get for getting data and post for creating it. It means your server doesn't remember anything between requests. Every request is self-contained or stateless. And it means you treat everything as a resource that has a unique URL. It's a clean, predictable way to build services. Let's be clear, security is not an afterthought. It's job number one. If you're building MVC apps, you have got to know how to defend against things like cross-site scripting and cross-site request forgery. And for your web APIs, the game is all about authentication. You'll need to talk intelligently about things like JSON Web Tokens or JWTs and OAuth to prove who is allowed to access your data.
And this quote really nails why they ask these questions. It's not about checking if you know a specific function name. They want to see if you can think like an architect. Can you design, structure, and, most importantly, secure a real application from the ground up? All right, let's level up. We're now at the top of the gauntlet, the architect's view. This is where we stop talking about just one application and start talking about entire systems. Performance, scalability, design patterns. This is what really separates a senior developer from the pack. You will absolutely be asked about design patterns, and the repository pattern is a huge one. So what's the big deal? Imagine a wall between your business logic and your database. That's the repository. It means your main application code doesn't care if you're using SQL Server or something else. This makes your code so much cleaner, way easier to test, and a heck of a lot simpler to maintain down the road.
Okay, data and performance, they go hand in hand. Think about it this way. Eager loading is like packing everything for a trip before you leave. You make one trip to the car, it's efficient, but you might be carrying stuff you don't need. Lazy loading is like going back to the house for each thing as you need it. It seems convenient at first, but you can end up making way too many trips, which we call the N+1 query problem. Knowing which strategy to use and when is absolutely critical.
When you're thinking like an architect, you've got a whole toolkit for performance and scalability. You've got caching to take the pressure off your database. You need API versioning so you can make changes without breaking your users' apps. You use compression to make your data smaller and faster to send. And, of course, you need amazing logging and monitoring, because that's how you know what's actually happening when your app is out in the wild. And that brings us to the final challenge. We've talked about theory, we've talked about principles, but none of that matters if you can't connect it to what you've actually done. This is where you become a storyteller. So when they ask you something like this, a huge mistake is to just give a technical answer. No, you need to tell a story. Set the scene. What was the problem? Then explain your mission. What were you tasked to do? Walk them through the steps you took. What tools did you use to figure it out? And finally, the big finish. What was the result? If you can say, I made it 80% faster, that's way more powerful. You're showing them how you think, not just what you know. Here's another chance to show off that architect's brain. The key here is to talk about your decisions and, more importantly, the why. We chose microservices because, or we considered a different caching strategy, but the trade-off was this proves you're not just following a tutorial, you're thinking about the big picture, about the long-term health of the system you're building. So there you have it. That's the playbook. We've laid out the questions they're going to ask. Now the only question left is, what are your answers going to be?